Welcome back, team. This is session 13. We'll create a standard load balancer with meta-argument count. Basic load balancer we created in the previous session. This is extension of that session. So in this session, we'll use meta-argument count for Azure Web Linux VM and network interface cards. We'll use meta-argument count for Azure standard load balancer for network interface card to load balancer associate resources, Splat expression and element function. We are going to make some changes into these files: Web Linux VM input variables, Terraform TF-vars. These are some changes in these files: Linux VM network interface card, Linux VM resource, output, load balancer resource, and web load balancer inbound rules, network address translation rules. Bastion Host, additional optional changes to the Bastion Host as we are enabling inbound network address translation NAT via load balancer Bastion Host. In this use case or demo, it is optional. If you want to use comment all the code in these files and no need to change, if you don't want to have Bastion Host created, like C801 Bastion Host input variable, C host 02 Bastion Host Linux VM, and move SSH key to Bastion Host and Bastion Host output. C8 part that can be completely ignored if you don't want Bastion Host part. Additional loads: meta-argument count, function element, and for each with maps for lookup, for searching, for mapping. C701 is Web Linux VM input variable. So in this we are creating these variables. This is a placeholder Web Linux VM instance count. How many instances we are creating? Default is 1. It's a number type. Then load balancer input NAT port for all VMs. This will be applicable for all VMs. It's a web load balancer input NAT port list, and it is a list type. It is a string, and this is a list of ports which are required for our load balancer as an example. Now consider this: if we are using Postgres, you may have to add 5432 port also for Postgres. If you are using MySQL 3306, and so on and so forth. So you have to add the list through the load balancer if you want to allow connection. This is incoming ports, inbound ports, incoming requests to be accepted on these ports. So you can decide which port you want to open through this list of items. Then TF-vars, environment, group name, group location, the VNet that will be created, the CIDR block, web subnet, app subnet, database subnet, Bastion Host. You can see all the subnet that will be created and the service subnet name that will be created for this. And instance count is 5. Web Linux VM instance count is 5, and we can change this number, how many instances we want to create. This file is terraform.tf-vars. So 5 instances will be created. Inbound NAT ports will be, these are the inbound node ports. Now Web Linux network interface .terraform. This is network interface count. How many network interface will be created? And this is coming from Web Linux VM instance count. That means 5. You can see for each one we are creating 1. The variable is coming from this variable. And the name, location, resource group has to be the same. IP configuration coming from the IP address, dynamic IP address allocation. Then Web Linux VM resource, the main resource which we are creating, virtual machine. The resource name, count, how many resource, Web Linux VM instance count. Again this will be 5. I'm going to make change into this file name because I don't want 5 instances to be created. It's going to create 5 instances. We'll create 4. Then name, computer name. So it is created by the prefix and the count number. You can see Linux VM number 1, number 2, because this will work as counter, and therefore each host name will be different with the count number. Resource group name, location, size, the shape that will be used, admin username, network interface IDs, and the SSH keys which are coming from the file. And then on disk, caching, storage count type, and then source image reference, the image that will be used, and the custom data if you want to add. This is base 64 local VM. This is the custom data not coming from this file. This is commented out. Then output that will be displayed, the public IP addresses, network interface output, the network interface IDs, then network interface private IP addresses, virtual machine public IP address, virtual machine private IP address, and 128-bit ID of the machine, and the machine ID. All these things will be displayed. Then this is a web load balancer resource that will be created, resource associate, network interface card, and standard load balancer coming from this Azure network interface backend address pool association, where we specify the count, network interface ID, IP configuration name, and the backend address pool ID. Then this is the inbound net rules, web load balancer inbound net rules, the rules that will be created. So depends on the virtual machine to effectively handle the Azure Resource Manager provider related dependency bug during the destroy. Count, name, protocol, front-end port, back-end port, front-end IP configuration name, and the resource group name, load balancer ID. We are attaching and associating the two. Associate load balancer net rules to the network interface, to the VM network interface card. Same, this is a association, IP configuration, and the rule ID. So let's execute the command. First step is we need to source env vars, because this is where we have our environment variable stored. Second, login. Once we are logged in, we are good to start Terraform. And let me make one change here. Instead of 5 instances, let's make 4 instances. And here instance that will be created 5. Instead of 5, let's create 4 instances. Terraform init. Initialization done. Let's verify. Terraform validate. Success. Terraform plan. Successful. And Terraform apply. Auto approve. This will apply. So this will create 4 instances, a load balancer, net rules association. All the resources will be created. This will take around 5 minutes. Let's log into the cloud in the meanwhile. So I'm on the on resources page. All resources, they are being created. You can see. I can refresh as they are being added one by one. This is our development web load balancer. Front-end IP, health probes. Right now I don't see anything. I know I will not be able to see because health takes time. And inbound net rules which we configured will come here. Right now they are not configured. We configured outbound rules also we configured. So we are expecting those rules here. And this is one web app rule, port number TCP IP port number 80. So this is one rule we've configured. We are expecting more rules. Similarly, balance IP at the addresses, front-end IP configuration. This is a web load balancer public IP address that has been configured. So you can see the IP address. This is the front end public IP address of our load balancer. Let's check the public IP, and that will be shown here also. Same, you can see the same public IP address shown here. Then this is the subnet. These are the subnet: Bastion subnet, app subnet, DB subnet. The host public IP address, Bastion host public IP address. So let's wait. I'm refreshing. See, all the resources, almost all resources are created. Linux VM 0, Linux VM 01, Linux VM 2, and there are more. Linux VM 3, Linux VM network interfaces card, network interface card 3, network interface cards. One more machine is expected. If you see, okay, started from 0, 0, 1, 2, 3, that means 4 machines are created. So this is my second machine as an example. So we can see all the machines are created, all the resources are created, and 24 resources are created. Let's see. Yeah, here also you can see all the resources. So this is the Bastion host public IP address. We could see all these things: network ID, network name, front end configuration, and then this public IP address, load balancer public IP address, the private IP addresses, then web Linux VM private IP addresses. We have 4 machines, so we got 4 public private IP addresses. So we could see all the resources created. Now we can verify the output, and we can try this. Execute this command: initialize, apply. We have done. Verify resources. We just now verified the resources, the machines. 4 machines are created based on the count, and network IP addresses. Let's check the rules also. Here I'll see the subnet, web subnet. Where is my web subnet? Yes, this is my VNIC, and here I will find the associated net association, and the configuration. This was here available. Network security group. Yeah, these are the network security groups. So this is one app subnet, Bastion subnet, DB subnet, web subnet. These are the security groups. So if I go back, I can see the machine also, and I can see the association. If you see the web interface, network interface card, the association of the network interface card with the machine, also you can see attached to this machine. This is the machine. The ID web's Linux VM number 3 is attached to this network interface card, and here you can see the IP addresses, IP address of the machine, public IP address, private IP address, virtual network subnet, and the DNS app. If you want to configure, you can configure. So all the resources you can see created as per the requirement, and if you want to connect, we can connect. I don't need to connect through this Bastion host because we demonstrated all these things earlier also. So let's destroy. And that's all for this session. Thank you very much, team.